Hello, ladies and gentlemen. So as promised, I told you I'd show you how to do this spreadsheet work for page 54, number 12. So one of the things that I'd like you to do, as we talked about in class, is to try and do this on your own. I'm giving you this spreadsheet. You can use it. You can also, if you've already attempted it, do your own spreadsheet and just attach that to the assignment. Either way. I've also, in this, here's a picture in here. I've also included the formulas that we use, so you can have those. It's important to note that we have some things in here that we've got our F given to us up here in the problem, and we've got our E, our modulus of elasticity, and we've got our L, which is the span. Now, what's really important with this one is that your span is given in feet, but everything else is in inches. So we're going to have to convert that to inches. So 12 feet, the span should really be L is 144 inches, not 12 feet, right? Okay, so let's go ahead and get started. First of all, we're going to need to make sure we know all of our variables. Now, I am doing this I haven't really prepared for this. I'm doing the best I can, so I may make some mistakes, and that's okay because that's kind of part of what we're learning. So zoom in on this a little bit. So first of all, we got to set up our categories. Try and zoom in here so I can, there we go. So I think that we need to, first of all, say, what is the board? Board? How about board? Cool. All right. And we're going to need to know some things about this, right? Because it's different orientations, we've got a base, we've got height, we've got then that variable of 12. We can deal with that in the equation. We are going to then have some things like our modulus of elasticity, right? So we're going to figure out what the, well, let's do this kind of in order. We're going to need to know what our area is. We're going to need to know our modulus of elasticity. I'll put that in as IXX. I don't think you can do subscript in a spreadsheet. Maybe let's try that and see what happens. Yeah, I don't think we can do that. And then we've got our modulus of elasticity, which is our E. We've got our L for our length. And we've got, what am I forgetting here? Oh, our force. Which is always going to be 220, I believe. Did we say a 250-pound force? All right, so let's list out what we've got. We've got a 2x6 vertical. We've got a 2x6 horizontal. And now I'm just going to drag these and change them. Okay, oops, that's not what I meant to do. If you hold down the control button, I believe it will keep those the same, and then I can go change it. Then we have a 2x8 in both orientations and a 2x10 in both orientations. Let's make sure we've got. Okay, so vertical, horizontal, and vertical, horizontal. So we have a 1.5 by, when it's vertical is the base, and it's 5.5 high. Okay, so go ahead and fill out the rest of this. And notice that I'm using the actual dimensions. tighten this up a little bit. I think I'll also make this a little bigger just so it's easier for people to see it. You do you. Okay, so now that we've got the size of our boards and the orientation, we're going to start figuring this out. Now, I hope that you'll do this on your own. We know that our area, for example, is equal to that times that. Uh-oh, what happened? I don't know what just happened there. Oops, I put an actual X for time. Times instead of an asterisk. There we go. All right, cool. Okay, now area is just showing us just a cross-sectional area. Now for our IXX, remember it's our formula here. So this is going to be equal to our base times our height to the power of 3. Now it's going to do order of operations. So, oops, divided by 12. I forgot that part. And 3. I guess we better put that in parentheses then. Divided by 12. All right, there we go. And we're going to drag this down. Now we can make a little prediction that I'm guessing that in the order of smallest to biggest is probably going to be 1, 2, 3, 4, 5, 6. It's going to be my guess. We'll see how if that looks that way. Yeah, so a 2x10 vertical has a lot of resistance to deformation. Let's go ahead and go 2 decimal points. 2 decimals. There we go. And again, you can kind of tighten this up as you go along. All right. Force is always going to be 250. If you hold the control button down while you drag that, it will apply the 250 to all of those. Whoops. Okay, let me try that again because you have to hit Shift and Control. Okay, it's holding the Shift key down while we do that. Our length is always going to be, remember it's in inches, 144. 1444. Okay. And again, I'm holding the Shift key down because that's always going to be like that. Now our E is also a given, which is 15 and 1,510,000. Okay, again, holding the Shift key down. Okay, tightening that up. Whoops, I think I held the control button down. Let's try that again. There we go. All right. Now, the one variable we didn't put in at the beginning, as I forgot, was to put in our actual deflection, which is the point. That's what we're finding out. There may be a way of putting a little triangle in there, but I think what I'll do is I'll just put that little guy to stand for delta max. Okay, now here's where we've got to put in our equation, right? So I'm going to move that picture over a bit. Okay. So our delta max is going to be equal to, and this is where we look at that equation, and it's equal to, I overuse parentheses, make sure I'm going to be in order. So it's going to be our force, okay, times our L to the power of 3 because it is caret 3 because it's cubed, divided by 48 times I, or 48 times E times I. So that's going to be 48 will be our constant times E. Could have typed it in, but times I. Enter. Okay. Something went wrong. No, what I did wrong is that I did need to do my order of operations, and I underused parentheses this time. So I had to put parentheses over all those things in the bottom of the equation. All right, now we should be able to apply those. And let's take it down to 2 decimal places. All right, so let's see if we were right. So we said that the verticals, the horizontals in order would be the most deflecting, right? So in other words, they're the weakest if it deflects the most. So that deflects most, next. Okay, makes sense. By the time we get to a 2x10 that's in a vertical orientation, it is deflecting it less than 1/8 of an inch with a 12-foot span. So that's a pretty strong board. That's why those things are supporting the floor of your house. Okay, cool. So now the last question is, it's asking us to, it says use Excel. We're using Google Spreadsheets. Create a deflection versus moment of inertia graph. I tried a line graph with this earlier and it didn't really work out the way I'd like. So we'll just try doing a bar graph. So insert a chart. This is saying a column chart. So it's going to ask us for a data range. We're going to put in 2 data ranges. Click on that little guy to select data range. And we're going to do our moment of inertia, which should show up, and then do our delta max. Okay, click OK. I actually haven't practiced this yet, so we'll see what happens. All right, so there we go. So we have our axes. It would be nice to label those axes. Let's see what we can do to add some labels here. I like what that did. And it shows us what our moment of inertia was. And then if we add labels for that, it's going to show us, okay, good. And then that little guy pops up right here also for showing us, what our deflection was at the same time, although those are showing us the same thing. Let's see if we can, it's adding labels for E2 to E7. No, I want those labels. There we go. That's showing us what the deflection was, including the one that we can barely even see. All right. So I'm not going to worry about showing labels and all that. Really, we should if we were presenting this, but we did want to see the relationship between our modulus of elasticity and the amount of deflection that it had. And so once you've got this done visually, that's good enough for this particular project. All right, have fun. Hope it worked out for you. See you later.